Here's problem 8.25. A 2 kilogram mass is projected vertically upward from ground level with an initial speed of 30 meters per second. The mass rises to a maximum height of 35 meters above the ground level. How much work is done on the mass by air resistance between the point of projection and the point of maximum height? Alright, so let's imagine what's going on here. We have a mass, 2 kilograms, being projected upward with a initial velocity, let's say a velocity at point A of 30 meters per second. And it's going to travel upward to some maximum height. Let's call this point B. And against the motion is going to be a frictional force over that total height. Point B is 35 meters above. So it's strictly a conservation of energy problem, and we want to find the work done by this air resistance. Now, the air resistance could be a constant force over that distance, but we don't know for sure. So the way to truly approach this in an exact way is to use the one equation to rule them all, our energy equation. So we're going to have that the kinetic energy at A plus the potential energy at A plus any work done along the way, which is what we want to find, is equal to the kinetic energy at B plus the potential energy at B. Now, we know that we're going to go as high as we can go and go no further, so our velocity at B is going to be 0, and hence our kinetic energy at B will be 0. Also, we can define our lowest height as being our 0 height. So our gravitational potential energy at A is going to be 0, and that would set our gravitational potential energy at B being mg height at B. Sounds good. So now we can solve for the work done on the system along the way, which is indeed the work done by air friction. And that's going to be equal to the potential energy at B minus the kinetic energy at A, which is going to be mg height at B minus 1/2 mass times the velocity at A squared, kinetic energy at A. Factor out the mass, so we have m times g height at B minus 1/2 velocity at A squared. And that's going to be 2 kilograms times 9.8, height at B is 35 meters, minus 1/2 times 30 meters per second squared. And this is equal to a negative 214 joules. So that is the work done along the way. That is the work done by air friction, a negative 214 joules. We really didn't have to know the force or the distance for that work, because we just find the full quantity using the one equation to rule them all.